As I mentioned before, Snowflake does not provide any functionality to generate fake or synthetic realistic data. It can generate different numbers with a random distribution or a specific distribution. You can generate rows with a generator functions. You can generate sequences with seek 1, 2, 4, 8, yeah, seek from sequence. But you'll not find anything close to realistic addresses, cities, city names, state names, or emails. For this, however, we can use a small, very useful library, a Python library called Faker, that you can easily install with just pip install Faker. In the lines of code I have on screen here, you will need to install also pandas, pip install pandas. Yeah, I did this before. It's very trivial. Yeah, I'll not waste time on this. What this sequence of code does is it will instantiate a faker object, and you see the very simple way we can generate different kinds of synthetic data. In this case, you call f name to generate names, address to generate fake but realistic addresses, city, state, email. Okay, and here I will pass 1 million. Okay, this will be for 1 million rows. Yes, and I'll pass this output into a pandas data frame. Which pandas data frame? Yeah, definitely later on we need to save it into a customer's fake CSV, comma separated value file, because later on we want to upload this into a Snowflake stage and then to load to copy all data into our customer fake Snowflake table. So a lot of things to do. I did this before twice actually, and this is what I got. You can see here on screen, yeah, the kind of data which was generated with names. Yeah, printing the data frame, yeah, will just show the first five and the last five rows from our 1 million rows. Uh, you can see we have email addresses, we have state names, city names, and yeah, that's it basically. When I looked at this, it took about 10 minutes. Definitely, as long as we want to populate some table data with this synthetic data, which was generated on our local file, we should try to avoid transferring a lot of data from our local environment into a stage and then into a table. So we've seen before that we can use, for instance, a Streamlit app in the Snowflake account add some to generate and add some Python code. So I just created here, as you see, another Streamlit app. It is important to note that Faker is already in the packages provided by Anaconda, so you don't have to install this separately, but you have to find Faker here and add it as a reference. Okay. For the rest, it depends right now. If you just want to show the data on screen, you don't even need the snowpark session here. But if you want to transfer the data into a table, yeah, definitely you can do it through the session of snowpark. Right here, just for demo purposes, I'll just generate 10,000 rows and pass this into a data frame. Yeah, this is a data frame provided by Streamlit. So, okay, so this could work, but let's do it in a different manner this time. Assuming you created a test database for this use case, we'll go to worksheets and we'll create this time not a typical SQL worksheet. We'll create a Python worksheet. Okay, and just replace the code that you'll see by default with our code from the GitHub repository specific for this Python worksheet. You'll find it there, and that's a code. Select the database that you use for test. Yeah, that's a challenge fake. Okay, that's the one I have, and then you'll have to go to packages, and just like before, yeah, make sure you have compute warehouse here selected, because otherwise you'll not be able to do anything here. Find faker here. So just like for a Streamlit app, you'll have to add a reference to faker. Okay, and then we'll just click run. We'll do it right away. Remember, we'll use an extra small warehouse with just one node. I think we set up everything. I'll just start this one, and we'll continue to look at the code a bit. What we do here, just like before, we generate fake data, 1 million rows, yeah, with faker, but we create a schema here. We take all data and we generate a table. Write mode, overwrite, save as table. Yep, sorry, I have the I have the internet sense over. Okay, so I will save everything directly from the data frame into a Snowflake table. Okay, here are some results. It took also a while, basically the same time we spent locally, over 10 minutes. So I executed this use case specifically with a much larger database, with a large database with 8 nodes. So 8 times more expensive. And I got the same results. This tells me, yes, that definitely this library faker, yeah, is not scalable enough. It doesn't matter if you have 10 nodes, 100 nodes, it is single threaded, it will execute, and it will take the time it requires to execute it in one single thread, one single node, whatever this node is. But you can see already, you can see the point. You may have some other kind of processor that would take advantage of a much better warehouse, a better machine, because in this case, the warehouse will act like an application server. One more thing left to do now that we have our data is to label it. And we can label it automatically because Snowflake has some built-in functions for automatic labeling of this kind of table columns based on their semantic. So, for instance, if we say select extract semantic categories, yeah, from our table, let's run it. We'll get one single cell with some JSON data. And basically, this will tell us that Snowflake has not been able to categorize our address, our city, but it identified, yeah, with high confidence the email, yes, as an identifier, the name as an identifier, also high confidence, and the state. You can see high confidence also, that's a US state or territory. Okay. Going forward, we can directly associate these labels with our table columns, and we'll call this call associate semantic category tags with the data from the extract semantic categories, basically the ones that we already run before. We'll do it again, but this time we'll apply the labels. Uh, there are other alternatives to pass through an intermediate table with this data, studying this data, eliminating what we don't need, making corrections, but that's the fastest way to label your data. Okay, so apply semantic categories to 3 columns. Okay, we can look in the information schema tag references all columns. Okay, to see what are the tags applied to each specific column. Yeah, so here you have it, folks.